So the next video here has another double line reflection. However, what we're going to do is we're going to reflect over two lines that are not parallel. Two lines that are not parallel in the same plane must be intersecting. So we have a point of intersection right there for these two lines. Okay. What we're going to do is I'm going to make that the mirror. I'm going to reflect this, this figure over that line. I'll label it and show labels. Good. Okay, and then we'll take this figure and we're going to reflect it again over that line. So double line reflection, and we'll let it label as well, and we'll take a look at what it looks like here. Okay, so show labels. All right, so what we want to focus on is the final image and the pre-image. Okay, so this is the final image right here. Clearly, it does not look like it was a translation like the other one did. Let's see if I can find that other one. Yeah, so this one, if we remember correctly, let me get rid of this. Get rid of that. So when we double line reflected, and there were parallel lines, it looks like it was a translation, or the single transformation that's equivalent is a translation. So now if we go over to a double line reflection, two line reflections, where the mirrors are intersecting or not parallel, okay, what it appears we get is definitely not a translation. You can see the slope there and the slope here. Those corresponding slopes are not the same. Another way to look at it is B moved a different amount than C. But what we do notice is, real quick, if you construct a circle centered at this point, what you're going to notice is it's possible that B was moving along a rotation, okay? So that is the possibility there. That's what we got to consider, okay? So I'm going to get rid of that. I'm going to also hide this. Oops. So we can get that out of the way, and we can really focus on these two figure, the pre-image and the image, final image. All right, so the claim is that you did notice, I'm going to claim that it is a rotation. The center of that rotation is going to be where the two lines cross. Now let's mess with these a little bit just so you can see. Okay, if I increase this, here's what's pretty neat. If I increase the angle, I increase the rotation. The center of that rotation is, in fact, at the point of intersection. And you can see that because B and B double prime here, when I do that, you can see B double prime is moving along that circle. So clearly that's a rotation. Okay. You can see, let's do this with A then. Sure. A is going to have the same effect. Okay, same thing, you're moving, if we change that angle, you see it, A double prime is moving along a circle, and hopefully that's pretty convincing, okay? So let's go over and summarize what just happened, and then we'll come back and look at some specifics. Okay, so what we have right now, as you can see, we're just going to summarize this, write down some notes on it. So if this is the pre-image, okay, and this is the final image after two line reflections that were the lines, the mirrors were not parallel. What we claim is that it was a rotation. Okay, let's get back over there. There we go. Okay, so two line reflections, a sequence of two line reflections. Where the mirrors, or the lines that we reflect over, where they're not parallel, is equivalent to a rotation. Now, what we got to work on is right here, okay? Just to say it's a rotation is not a complete response because we can do better. A rotation needs to have a center and an angle, and we can figure those both out, okay? So it is equivalent to a rotation centered at the point where the mirrors intersect with an angle of, now I'm going to come back and fill in the blank here, okay? Let's go back over to Geometry Sketchpad and investigate that. Just show you some different things over there. Okay, back over at Geometry Sketchpad, if you remember, we reflected. First, we took this pre-image, reflected over this line. Okay, then we took that image, we reflected it over this line, and produced the final image after two line reflections. It's going to be a rotation, and it's centered right here where the mirrors intersect. Now we got to figure out the angle. The angle's a little more tricky. Okay, what I'm trying to show you is I like to teach my students that B, so each point, specifically B, moved along a circle. Okay. Now, if we really look carefully at this circle, okay, I'm going to put these lines right here. Give me a second here while I do this. I'm going to have construct some segments, but then I'll get rid of them. I'm going to make them dashed here in a minute. Okay, so these are going to be dashed. So let's just imagine. Okay, so B traveled, obviously this is the wrong way from here to here. We know it's a negative angle, but we'll just get the number first, and then we'll figure it out from there. But B traveled along this path over to B double prime, so that's a rotation. Now, what I want to show you quickly here is let's just reflect B. Okay? Just reflect B, put that back, so that's B prime. Here's what you're going to notice. This angle right here, okay, and I'll show you over on the other point as well. That's going to be the same as from B prime to here to here. Okay, now that doesn't seem like a whole lot, but it's starting to become clear because there's this angle too, this B prime to here. Let's just call that point O. All right, so B prime to here to here. That angle right there is going to be the same as this one. Okay, let me just show you that. So what I want to do right now is I'm going to calculate this angle. I'm going to let the program here measure it. 43.79. Maybe I can get that to 44. Close enough, right? It's essentially 44 if we round it. Okay. Now, what I'm going to claim is that whatever this angle between the two lines is, the angle between the two lines that we passed through is 44 degrees. I'm going to tell you that this angle is going to be double it. So watch what happens. It's going to double. Just like our distance doubled in the translation over in the other double line reflection. So this angle is double the angle between the lines. Now, let me just show you why. Okay, so if you measure the angle from E to O to B prime, okay, let's just measure that, 17.64. My claim is that this is going to be the same exact angle. Okay, and it is. So whatever this angle is right here, let's just draw that in lightly as well. Whatever this angle is right here is the same as that one. All right, and here's what's going to happen. The same thing's going to happen over here. Whatever that angle is, right, is going to be the same as this one. So that's why it doubled, okay, because you got to match basically. So whatever this is matched over there. Whatever this is matched over there because it's a line reflection on either side. So that's what really quickly I'm going to go and I'm going to show you on the other form. Okay. Okay, so we're back over here. I wanted to finish this statement right here. So when we have the two line reflections, we know that it's equivalent to a rotation, but then we got to be specific. Where's the center? The center is where the two mirrors cross. Okay. Now, what's the angle? Angle is going to be with an angle that is double the angle between the two lines, the two mirrors. Okay. Now, somebody asked me a really great question in my class. What if they give you, say, this angle? Because there's two angles between the two lines, which I get. What if they tell you this is 120 degrees? It's not that, but let's say it is. What if this angle out here is 120? Is the angle from here to here to here 240? Well, no. What you would do is you do 180 minus 120 is 60. This is one option. Sorry, the touchscreen. So what I did is 180 minus 120 is 60. So it's 60 from here to here. That would mean B to the center of rotation over to D, B double prime would be double, 120. Now that's of course in the wrong direction, so somebody could consider that as well. But I kind of look at it like this. It's double the angle that we kind of pass through here, So to go from here to here, that's where the first image would land, then we go over to there. That's one way to look at it, okay? Of course, you can consider going the other way, but, I try to keep it as simple as possible. All right, so let's just explain why. I know I did over there, but let's put some numbers to it. Now, let's say that this angle here, right, we were just talking about this one right here. Let's say altogether it's 44 degrees, altogether, right, the whole thing. Now, let's just say this piece of it, make it easier numbers to work with, is 20, right? Now, because of a line reflection, all right, whatever this angle is, that's the same. And then if we use 20, there's 24 left, which makes this 24. So that is exactly why we end up doubling the angle, because you have a match for either portion of it. So, you have a 20 plus 24 between the two lines, all right, that's 44. But you basically have two 20s plus two 24s is how a point is going to travel from its pre-image all the way to its final image. So you basically are doubling it. So you get 44 plus 48 is 88. So basically, if you figure out the angle between the two mirrors is 44, the angle of rotation is 88 degrees. Double it. Okay? So we're going to double the angle between the mirrors. All right. So thanks for tuning in. Hopefully this was helpful.